You name your classes customer, order, and invoice. You set up the properties. It feels like you're doing domain-driven design, but the names on the surface often hide a structural mess underneath. We call this an anemic domain model. The nouns exist, but they only hold data. They have no behavior. The actual rules of the business get pushed out into bloated procedural scripts. Look at this pricing system. It calculates prices successfully, but to get a final number, the application runs through a massive scattered tree of if statements, checking customer tiers, geographic regions, and active dates. We brush this off as technical debt, but it's a modeling failure. The logic is scattered because a crucial concept has nowhere to live. Effective models do not come from perfectly mapping obvious physical nouns. They come from hunking down the invisible concepts that govern the system and bringing them into the light. When you leave business logic implicit, buried in conditionals, the code and the reality of the business split apart. Scaling the system becomes a game of guessing where the rules live. To find those missing concepts, you have to look up from the IDE and observe the real-world business environment. Watch for signs of internal friction in the code. When you see methods with 8 parameters or identical validation rules copied across 3 different services, the codebase is signaling that a concept is missing. You will hear it in conversation too. Domain experts rarely speak in nested if-else logic. They use precise, condensed terms to describe the rules they navigate every day. That shared vocabulary is the ubiquitous language. If an expert uses a term in a meeting, that exact term must exist explicitly in the codebase. This chart shows how we expand our object-oriented taxonomy. We are taught to model things you can touch, like a user or a product. But we also need to model invisible realities, constraints, processes, specifications, and policies. If you only model the physical nouns, the actual rules of the business will remain trapped inside untestable procedural glue. Let's apply this shift to that sprawling conditional mess in the pricing system. Instead of evaluating customer tiers and active dates directly in the pricing script, we extract that specific logic completely out of the calculation. We use the specification pattern to encapsulate scattered rules into a cohesive module called discount eligibility. When rules change, we update one file. It locks into place and tests in isolation without spinning up the entire pricing engine. This forms the core loop of domain-driven design. Step 1, notice the friction and awkwardness in the code. Step 2, take that awkwardness to the domain experts. Discuss it, figure out what it actually means, and name it using the ubiquitous language. Step 3, model the newly named concept, refactor the code to match, and test it against reality to see if the friction disappears. Extracting a concept is an exercise in structural alignment. It forces the architecture to explicitly document the intent of the business. In the ideal state, the codebase reads like the business language. A new developer can open a module and immediately understand what the business is trying to achieve. But you have to watch out for common pitfalls. Don't brush off complex conditionals as harmless. Avoid dumping logic into generic manager classes, and don't over-engineer every minor rule into a dedicated object. This context map shows what happens next. Once you extract these implicit concepts, you have to strictly map their boundaries, like keeping customer management separate from policy management. Without strict borders, models fragment, and responsibilities overlap across the enterprise. Domain-driven design is an act of continuous discovery. The first iteration of any domain model will always be shallow, and the code will need to evolve as your understanding deepens. The mark of a senior engineer is a codebase that tells the uncompromising truth about the business reality.